All right, it's time for video 98. Get your calculators ready. Set
And pens.
Statistical tests.
Yes. So we're doing differences of means. We started this today in class, but we just thought we'd just do an example and just to refresh it.
All right.
Our mind. All right. So these are very similar to the difference of proportions, okay, and even testing for one mean, but we just have two now. All right. So
formula is not quite as bad.
No, it is not. A factory hiring people to work on an assembly line gives job applicants a test for manual agility.
What does that mean? I'm going to interrupt. How well you can use your hands?
Fingers.
All right.
Yeah. It probably should have been like
make them play the piano.
I think it should have been like dexterity, but whatever. Yeah. All right. This test counts how many strangely shaped pegs the applicant could fit into the matching holes in 1 minute period. The mean number of pegs for the 50 males tested was 19.39.
Go males!
With a standard deviation of 2.52.
We rule this peg thing.
Yeah, I think we do.
Okay.
The 50 females had a mean of 17.91 with a standard deviation of 3.39. So you are right. We are currently ruling the peg thing. However, is there evidence that that's actually the case?
Okay. So, is there evidence of difference? Okay, so let's start with the hypothesis.
Okay, so, well,
first
HO, so I want the mean of males equals the mean of females.
Yeah, use M and F, keeps it straight, or 1 and 2, whatever. Okay, so.
Yeah, sometimes it helps just to describe it so you know what the heck you're doing.
Yeah.
All right.
So that means the difference is 0 when we get to the formula.
Mm-hmm. So here, males does not equal females.
So it's a two-tailed test.
Yes, it is.
Not that we're not using our calculator for this one anyway.
Right.
Okay.
Two tails. Okay, so.
Who were the conditions?
Yeah, it doesn't really say much.
Were they random?
Again, it doesn't say.
Okay, so we have to assume.
We would assume it's representative.
Representative. Is it less than 10% of the males and females in the world?
I would assume so, yes.
Okay. Are they nearly normal?
That we don't know, because all they gave us was the statistics.
Right, but you know what? Since it's 50 males and 50 females,
they're symmetrical.
In that case, since it's 50 males and 50 females, it doesn't matter because they're both large sample.
Right, that's true.
So we could get away with Z. We'll use
T. We actually could use the Z test. You're right.
We'll use T, and we don't. The nearly normal conditions satisfied. It doesn't matter. It's a large sample. Okay, then there's one more.
There's independence.
Are they independent groups? We assume the males and females were selected independently, right?
Yes.
Okay. All right. So again, if it doesn't state, we have to say that we're assuming that.
Okay.
I think you covered yourself that way. All right. What test are we doing?
We're going to use the T-test.
What kind of T-test?
The two-sample.
Yes, we are.
Okay.
The two-sample T-test, or showing the formula. So either name the test or show the formula. And I like to show the formula anyway when I'm doing the computation.
Yeah, probably like.
This one's kind of hard to remember though.
I mean, what I always kind of tell my class is, do it on the calculator. It gives you all the stuff, and then you kind of fill it in the formula. Yeah. That way you show your work. You kind of know you're getting the right answer. You can check yourself that way.
I think it's true for all the things we've done.
Yeah.
Actually, so we kind of know what's going on both ways.
Mm-hmm.
All right. So we use the two-sample T-tests. Okay.
So we want to do subtracting the two means.
Yeah. So we're going to show the formula. So the difference in the averages.
Mm-hmm.
I would put that in parentheses.
All right.
Just to emphasize that that's the estimate.
And we were subtracting it from 0.
That's our null hypothesis that the means are equal.
Correct.
So that's the true difference, or what we're assuming. Divided by the standard error. You want to compute that on the side or something, or?
Well, or we could just show the square root.
All right. So
the square root, it's the standard deviation of group 1, which was 2.52 squared, divided by the number of males, which was 50, plus 3.39, standard deviation of the females, squared over 50. So pretty much we're adding the two variances together, like we are normally used to. And so I'll plug all this jazz in.
You waiting for me?
You're the calculator guy.
All right. I'm just going to give you the final t value, okay? So
That works.
you probably, yeah, that'll be fine. So in class, we calculated the standard error separately and then put it together in the formula. Either way. All right, N2 was 50. All right, so doing a two-tailed test. Never pool on this.
Nope,
I don't
no
think.
pooling. We'll even make a note out there. No pool.
Save that for the experts. Okay, so the t value I get is 2.48. And we should list the degrees of freedom. So we get 90.49. I have my class put in parentheses that they got it from the calculator.
Okay.
So they know it was just from a formula or what. So I just put in parentheses calculator after that.
Mm-hmm.
Okay, so we know where we got the degrees of freedom. There's a complicated formula for that. You don't have to worry about it.
There is.
All right. What else do we need, Mr. Lewis?
We're probably going to need a p-value.
We do. The p-value is 0.015.
0.015.
Okay.
So, well, it doesn't really give us the alpha, but I'm assuming it's 0.05.
Yeah. Either way, this is 1.5%.
Well, I mean, if it's at the 99th percentile, we're not rejecting anything.
That's true, but I think, since it didn't say, I would assume that 1% or 1.5% we would reject.
We are rejecting
So, Mr. Lewis, I know you're not going to write it.
HO. Yeah, because I'm kind
Could
of
you
out
give
of
it
room.
verbally?
I can. So we would reject our null hypothesis that the means were equal in favor of the alternative in which the means of the two groups are not equal because of our t statistic of 2.48 and p-value of 0.015, which is less than our alpha statistic of 0.05, which they didn't really give us.
In my class, we had a debate.
Yes.
Would they accept this on the test, that if the p is too low, reject the whole?
Probably not,
All right. So
but
we'll go with what you said.
that is a nice saying. So
It is what it is.
we're gonna conclude that males and females have a different mean manual agility.
Okay.
We're not saying any group
Can I
is
hit
better than another group.
Can I hit the journal assignment button?
You can.
Wow.
It's like going to warp speed.
Okay.
Okay, this is a lot of words, but really not that bad. Okay, so for your guys' journal assignment, we have the American League baseball teams that play their games with a designated hitter. Bunch of cheaters. Meaning that the pitchers don't bat. The league believes that replacing the pitcher with another player in the batting order produces more runs and generates more interest among fans. The average number of runs scored in the National League, 16 teams, was 9.58 with a standard deviation of 1.55. The average for the American League of only 14 teams was 9.8 with a standard deviation of 0.80. Assume both samples are representative, independent, and nearly normally distributed.
Everything you want.
Yes, it is. Is there evidence that there is a difference in the runs of the two leagues?
What's step one?
Always state your hypothesis.
What would be step two?
Check the conditions.
Step three?
Find the t statistic and p-value,
Or state the test.
or state the test.
And then show the mechanics.
Right.
And then step four?
Would be to conclude.
Yep. Step five?
Go
hit the fridge.
Yeah, get a Coke or something.
Pat yourself on the back. All right.
Start AP English homework. All right.